Hello everyone. Today is actually January 1st, but yesterday I was not able to record another video for you, so you can watch it from today. Today is actually our last slot in our Coding Advent Calendar for the past year, for December 2022. So let's open it and see what's inside. Here is the problem. Unique path variant 3. You're giving an m to n integer array grid where grid ij could be 1 representing a starting square. There is exactly one starting square. 2 representing the ending square. There is exactly one ending square. 0 representing empty squares we can walk over. And -1 representing obstacles that we cannot walk over. Running the number of 4 returns the number of 4 directional walks from the starting square to the ending square that walk over every non-obstacle exactly once. Okay, here we can go right, down, left, down, right. Or we can go down, right, up, right, down, left, down. So 2 variants. Here there are 4 variants how this can be done, but eventually we need to find all of them. How are we going to do this? So first of all, we have grid, and it's the thing inside of it. We don't know where are we going to start. So first of all, I offer you to scan this grid a little bit to find the start row and start column. Let's call this scan game field grid, and we have a private void function scan game field. Okay. If grid row column equal to 1, it's representing starting square, then start row equal to row, and start column equal to column. And also it would be nice to know how many empty squares there are in this field, because we have to find path that walks over all of them. So it would be easier if we know how many of them there are. So we will do the following. If zero, then we will increment number of available cells. That's it. That's the scan game field grid. And let's do the following. How are we going to do this? So we know the number of available cells, and we know the starting point. From starting point we can go to 4 directions. So let's imagine we have a function called DFS, because we are going to use depth first search, and we need to pass there the grid. We need to pass their starting row +1. We need to pass their starting column, and we need to pass there the number of cells we just visited. So it is 0 yet, and we need to do this 4 times with different directions, like this: -1 and -1. Okay, so we do this for 4 directions, and we suppose that this function DFS will help us to solve the problem. And to do this, we are going to create additional variable here. And this variable will be modified inside the algorithm. Return this answer. So now we just need to create this function. How are we going to do this? It will be a void function, DFS. It will accept the grid. It will accept starting, like row, integer column, and integer passed cells. So let's implement this DFS function. How it should look like. First of all, we need to check out of array conditions. In this case, if a row is less than 0, or column is less than 0, or row is more or equal to grid length, or column is more or equal than grid row length, then we don't need to do anything and we just return. Okay, that's covered. Then let's take a value from the current position. And let's look at it. So if the value is starting position, then we don't need to do anything as well, right? If value is -1, this is an obstacle and we cannot move here, so we also will not do anything. And also we need to check that this concrete place has not been visited before, and we are going to mark all paths on the way with additional value here, -2. And in order to not have a cycle in our field, we will not move to the place we already have in our path. We are not going to store our path somewhere. It will be stored directly in the field, and we will maintain these values. We will remove them later on. So it's not obstacle, it's not starting point, and it's not an ending point. So here it should be -2, and in this case we also return doing nothing. If value equal to 2, which is our ending point, right, we need to do the following. If past cells equal to number of available cells, that means we met both our requirements. We found an ending point and we also visited all available cells. That means in this case we need to increase our answer by 1. So if past cells equal to available cells, then we are going to do this answer ++. And in any other case we need to return, because we cannot move anywhere else from this position, because we already found an ending point and we cannot like move away from it and return back. Okay, what are other options? So it is obvious that the only value left is 0, right? Then we consider changing this place to -2. Okay, and we also are going to start recursive calls from this position, moving to 4 different directions. And once we're done with all our recursive calls from this point, we have to change value of this place back to 0, because this field can be involved in different recursive calls from different stack frame, and it should be 0 again. Okay, what else? We need also to increment the number of past cells, because we found a vacant place which is not the ending. And what we do next, we just call this 4 times like this. So recursive calls yeah, a row plus 1 column. We are going to do this. Row column plus 1 and past cells. Row minus 1 and column and row column minus 1 past cells. That should be it actually. Let's quickly have some check. Looks like all of them are valid. So let's submit it. Okay, it is accepted and we beat 96, almost 97% of all submitted answers. The time complexity for this solution is big O of 3 to the power of n, and the space complexity is big O of n. Can you see why? But I anyways should congratulate you with a new year, new 2023, and I would like to wish you zero downtime, green tests, predictive deployments, fast compilations, challenging problems, efficient algorithms, reliable production environments, friendly colleagues, and competitive salaries. Happy New Year, guys!